Okay, so we'll now continue with the discussion on displacement of beams, and from calculus what we know is 1 over rho now the expression for y of x for the beam there's a name for this. This is called the elastic curve. We have seen a bit of this in the last class, but let me do this in detail today. Now, given the material properties of the beam, the deflections are such that dy by dx is very small, and so and this I already wrote 1 over rho therefore can be written as the second derivative of y, and this we know is equal to mx upon ei. So therefore ei now assuming that the beam is made up of the same material and the same cross section. So E and I will not change. So we can integrate this. And what we have said is dy by dx this can be written as theta of x, and this is the slope of the deflection of the beam, and dy by dx so now what we realize is in this expression, if m of x has the same form, then we can integrate. And if m of x changes, then we will have piecewise continuous distributions of y of x. So now m of x we know. M of x, so if m of x has the same functionality with respect to x, if we have a distributed loading W of x, then we have seen in the last class that the moment is related to the distributed loading. That means let's look at a case like this. This is the elastic curve which we are talking about. But we also know that dm by dx is equal to v. So this will give us so if we have the loading which is given to us as W of x, then we can relate it to the fourth derivative of y, because dm by dx is equal to v and dv by dx is equal to minus w, and using those relations we get the fourth derivative of y is equal to minus w of x upon vi. Now, of course, we know at the boundary conditions, we have seen at supported ends, the deflection is 0. dy by dx is equal to 0 at a fixed end. Y is also equal to 0 and dy by dx is also equal to 0. And at a free end, suppose we have a free end B. What condition do we have at the free end? Pardon? Shear force and bending moment will be 0. At the free end B, the deflection will not be 0. At the free end B, so at a free end B, for example, so here what we will have is V is equal to 0 and M is equal to 0. On simply supported ends, what will be the condition in shear force and bending moment? What will be the bending moment? The bending moment on the free end, on the simply supported ends, will be 0. Because what is the bending moment? If you start from a corner, it will be Ra times x. And when x tends to 0, it will be 0. Similarly, you start from the other side, it will be Rb times x with a plus or a minus sign. So on a simply supported end, for example, C and D, R will not be 0, but M will be 0. So now let's look at an example. And one of the reasons why we are doing this is, first we will see statically determinate problems. In statically determinate problems, you'll realize all we have to do is integrate the bending moment diagram and get our answers. But what I will come to in this lecture is that this becomes a very good method to solve statically indeterminate problems. And let's see how to do that. So, and I'm taking up examples. I will take up more examples here because you will not get to see this in the tutorial. So, let's take a very simple example to start with. So, this is a statically determinate problem, a very simple problem. A load P acting at L by 4 from the left for a beam whose total length is L. So, what will be the, so the first step is to find the reactions. So, we draw the free body diagram. What is Ra and what is Rb? Can everyone find this? If there is anyone who cannot find this, then please come and talk to me. I will explain these things to you, but this is something you should be able to do. How do you find RA and RB? Just take moments about RA plus RB must be equal to P, and take moments about one of the points, you will get equal to 0. So you so RB is equal to P by 4. RA is equal to 3P by 4. So this is A, this is D, this is B. So now if we have to draw the elastic curve of the beam, the first thing is to draw the shear force diagram or the bending moment diagram, or write the expressions for those. Okay. Now we can straight away start from the bending moment here, that for 0 is less than x is less than L by 4, the bending moment is what? RA times the distance. See, our rule was if a force Px plus P, it causes a bending moment equal to P times zeta, where zeta is the distance from where the force acts. So now, the bending moment is equal to 3P by 4 times x. Does anyone have any issues in trying to understand this? Can you write this directly? I think you should practice enough to be able to get these things. We will be doing more complex cases. This is the simplest case. I don't think you should expect this in any exam. But let's go through this. So this is how this looks like. So therefore, let's say the deflection in this zone is y1. So I get EI d2 y1 by dx square is equal to 3p x by 4. So EI times y1 So I have integrated it twice and got this expression. Okay. Now, from D to B, see, because from A to D, we have the same expression for the bending moment. From D to B, the expression changes. So therefore, the equation for the deflection will also change. And let's call that as y2. And first, so now, what is the expression for bending moment? So we start with the first force, it is 3p by 4 on all elements to its right. It will cause 3p by 4 times x. Then we will have, then there is a force of minus p acting, and any section to its right, how much will be the distance? The distance of p will be p times, the distance will be x minus L by 4. So minus p times x minus L by 4. So then we will add minus p times x minus L by 4. So this becomes equal to P by 4 times L minus x, and this is equal to EI d2y2 by dx square. Okay. Now these, so from here you can get the expression for y2 or EI y2 will be equal to minus P x cube upon 24 plus PL x square upon 8 plus C3x plus C4. You integrated 2 times, there will be 2 constants of integration which will be different from the earlier ones. We call them C3 and C4. Okay. So now we need total of 4 boundary conditions. To get C1, C2, C3, C4, we will need 4 boundary conditions. What are the 4 boundary conditions? One is, now y1 is 0 at x is equal to 0. There is no boundary condition on slope here at y1 is equal to 0. Because it's a reaction, there is no fixed end. Similarly, y2 is equal to 0 at x is equal to L. Then we will get so these are the 4 boundary conditions and with which we can then get our answer. Okay. So I think all of you should be able to solve these. This should be a straightforward. Now, let us try to extend this analysis to statically indeterminate. And what you will realize is why we are able to solve statically indeterminate problems is because the statically indeterminate problems will come when there is an extra constraint, and that constraint gives us a relation for the displacement, and we have an equation for the displacement. Let's have a look at this. Suppose we have a problem like this. A fixed end beam which is on a support like this. So this is a statically indeterminate problem. Why? Because when I solve this, you draw the free body diagram, you will have RA, MA, P, RB. So clearly, this is a statically indeterminate problem. Now, can we find RA and RB? And it turns out, using equilibrium, we cannot solve this problem. But if we use the equations of deflection, then we have some more, this thing that the deflection at point B must be 0. And this fact, along with the properties of the material, will help us to solve RB. And let us see how to do that. And So as an example 2, and for ease of solution, what I'll do is I'll invert the problem. Let this be the end B. And I'm considering this problem. Actually, here, when I draw the free body diagram, I should also put the X force, which, of course, when I will turn out to be 0, but and the reason why I'm taking this in this way is because the way we have defined the bending moment, you'll see it becomes a bit easier because, so let's start. So let's draw the free body diagram of this. The free body diagram of this beam this is a roller support. So RAX is 0. I don't need to write this. When I draw the free body diagram at A, because there's a roller, so the force will only come in the vertical direction. So RAX is 0 should not be written. I should just write it as RA. And then what we have is at end B, I will have BY, I will have BX. Now it turns out if I start from x is equal to 0 to L, the bending moment equation stays the same. What is the bending moment equation? What is M equal to? At any distance x, what is the bending moment in terms of these variables? Okay. Anyone else? What's the expression for the bending moment? There's a force RA in the positive direction and there's a force P in the minus direction. So the net force is what? RA minus P. And at any x, it is acting at a distance x. So it will be RA minus P multiplied by x. And that continues from 0 to L. So the bending moment M is equal to RA minus P times x. So that means EI d2y by dx square is equal to RA minus P times x. Now, I don't know RA. P is given to me, so I then continue to integrate this and EI times y is equal to RA minus P So now in this expression, I don't need to write y1 and y2 because it's the same shape. There are three unknowns, RA, C1 and C2. And what are the boundary conditions which I have? What is y of 0? This is 0. What is y of L? At x is equal to L, we have a fixed end. So what is the deflection there? 0. And what is the slope at x is equal to L? That's a fixed end. So what will be the slope there? What is the slope at end B? It will be 0. So therefore, now I have 3 unknowns and 3 boundary conditions, and using these we will get RA, C1 and C2. So therefore, a statically indeterminate problem by using the constraints of deflection can be solved to get there. See, I am starting from x is equal to 0. So I have not yet reached x is equal to L. If I start from the other end, and I think that's why I inverted the problem. See, had I started from x, if I take my x from the other side, then what will happen? See, what will happen is first you have to account for MB. There will be a minus MB on everything. See, we talked of equation starting from left. From right, there will be the opposite sign. So there will be a contribution due to MB and there is a contribution due to BY. So MB plus BY times X or minus BY times X. That will be the bending moment. And then you have to integrate this. You will get 2 unknowns, MB as well as BY. You can do the same thing. And there, then RA will not come into picture at all. Okay? And again, when you solve this, and then you'll also have to use equations of equilibrium along with the boundary conditions, because there then in your expression, you'll get C1, C2, MB and BY. So then you'll also have to use the equation of equilibrium to get the second relation. Okay? Here you get RA directly, and then you can use equations of equilibrium. RA plus BY must be equal to P, so you'll get BY, and then you can take moments about point A or moments about point B to get MB. When you take moments about point B, will MB count or not? Okay, if you write sum of moments about point B is equal to 0, what will you get? RA times L minus P times L plus MB is equal to 0. MB will not go away when you take moments about point B. It's a concentrated moment, it will stay. Forces will not cause any movement, but moment will stay. So then you can solve this. So this is how one can use statically indeterminate. Now, let us solve one more problem, which will be these problems were slightly easier. Let's take something which is I take a linearly distributed load where the load is W0 per unit length at the end L. So the problem is given a beam which is loaded like this, a statically indeterminate beam, find the reaction at A, equation of the elastic curve and the slope at A. So of course, our equation is let's first draw the free body diagram of the entire beam. So first I draw the forces due to the supports. At A, I have an AY. At B, there is a BX, BY, and a moment about B. And then now I have to represent this load. The total load, when we have a linear load, what is the total load? It is the area under the curve. So what's the area under the curve? Area under the curve will be equal to half W0 L. Okay? And where does it act? It acts at the centroid of this area. So this will act at 2L by 3 from A. So that means in this free body diagram, I will get W0 L by 2 at a distance of 2L by 3. So now I can get a relation. This will give me a relation. So this will tell us AY plus BY is equal to W0 L by 2. Bx is 0. We take moments about B. So we get MB okay. So this gives us one relation between MB and AY. I probably will not even be needed, but let's just. Now, we have to find the expression for m of x. Now, looking at this beam, will there be two deflection, two type of y1, y2 or only one y of x? Just as we saw in the first problem we solved, there was a point force, so there was y1 and there was y2. Now here, will it be the same shape or will it be different, two different shapes? Does the expression for moment of x, will it change with x, or it will obviously change with x, but will it have the same functionality or will the functionality change as you go from 0 to L? The functionality will stay the same because there is a load acting and there is a distributed force acting which has the same form. So you will get some function of x. Obviously, things will change with x, but y will have the same form. So that means let's write the expression for m of x. So we cut a section x. What will be the moment? And let's do things in a very simple way, straightforward way. First, let's write the contribution due to AY. What will be the moment at this cut section due to AY? AY times x. Okay. Now, so that means basically what we are doing is there is a V and there is a M. We don't need V, so that's why I'm not writing the expression for V. So moment is equal to AY times x. Now, what is this maximum value here? This will be W0 times x by L. That is what this is. So therefore, how much will be, now this is minus, so there's a minus sign. Now first let's write how much is the area under this curve. W0 x by L times x divided by 2. Okay. So let's just work it out. So the force will be minus W0 x by L times x. So this is the load sorry, एक minute, let me, I'll write this again. Let's do it slowly. The load is W0 x by L times x by 2. This is the load, W0 x by L times x by 2. And this is acting at what distance? This is acting at 2x by 3 from this, and from the cut section, this is at a distance of x by 3. Distance from the cut section. That is all what you need to know. So now all you have is this must be equal to EI d2y by dx square. So this gives you EI Is there any mistake? Pardon? L should be नहीं L नहीं होना चाहिए एक मिनट नहीं डिनोमिनेटर सॉरी ओके मैंने क्या किया हुआ है L should be in the denominator that's right ये जानबूझ के गलत लिखा था I wanted somebody to catch the mistake okay so now how do you solve this what are the three boundary conditions again the same as before at x is equal to 0 y is 0 at x is equal to L y is 0 at x is equal to L dy by dx is 0 so put these three boundary conditions you will get C1 C2 and AY so your answer reaction at y comes you have to find the slope you put dy by dx so you will get all your answers is that fine so this is also I took this example to tell you how to take care of the distributed load. Normally, if there is something more complex, a parabolic load, you just have to put the parabolic formula, W of x, and then get the bending moment from there and get to this. Okay. So this sort of tells us one way how these problems can be solved. Now it turns out that we can also solve these problems with another method which is called the method of superposition. Here what we have is, if we look at the if we compute the slope and deflection due to each load separately and then we add them up. That means if there are three loads acting, let me assume there is only one load acting, calculate the deflection at any point because of that one load. Then I assume only the second load is acting. The load could be force or a moment. And I find the deflection due to the second load. And then I find the deflection due to the third load. Then, and if I add them up, my question is, will we get the deflection and the slope due to the combined loads? That means, in effect, what I am asking is, does superposition work? आज मुझे लग रहा है बहुत सब लोग अपनी अपनी बातें किए जा रहे हैं क्या हो क्या रहा है होमवर्क कलेक्ट कर लिया क्या नहीं किया कर लिया कर लिए सबके होमवर्क कलेक्ट नहीं किया अभी कर लिए हैं ठीक है कर रहे हैं तो क्या होमवर्क हो रहा है क्या अभी लग नहीं रहा मुझे होमवर्क हो रहा है और कुछ मतलब देयर समथिंग मोर इंटरेस्टिंग तो अगर तुम फोन पे कुछ अच्छा सा देख रहे हो तो यहीं पे उसको प्रोजेक्ट कर देते हैं लेट अस ऑल सी दैट assuming it is something which all of us can see together but so anyways पता नहीं क्या पीछे पीछे क्या चल रहा है okay so now if I make a statement when does superposition work In equations or in mathematical equations, when does superposition work? If you have a differential equation, if y1 is a solution and if y2 is a solution, then when is y1 plus y2 also a solution? And that is if the equation is linear. If the governing equation is a linear equation, then superposition will work. So, the answer to this is that if and this is one thing which I am telling you. So, you should realize that this works not only in this course. In any mathematical equation, you may come across equations in different courses in different formats. In fluid mechanics also this will come, and linearity goes with superposition. If equations are linear, then the solutions can be superposed. So, here our equation is what? EI now what do I mean by linearity? Linearity means the dependent variable. What's the meaning of linearity? The dependent variable, in this case, the dependent variable is y. X is the independent variable. Y depends on x. That should occur as power 1. So, if x comes as x square, x cube, it does not matter. But y should only occur as power 1 in this equation. So, as long as E, I or M do not depend upon y, this equation is linear. And then we can superpose y or dy by dx. And therefore, linearity is going to work here. And so, if we have an equation like d2y by dx square is equal to y, that is a linear equation. But if I have d2y by dx square is equal to y square, it becomes non-linear. d2y by dx square is equal to sine of y, that becomes non-linear. But if I have d2y by dx square is equal to x square, that is a linear equation. So, here because now to use To use superposition, we use tables where standard loading and the deflection so let's look at now if I give you a problem like this, I will give you this table. The table will be given to you from where, and I'll solve a very simple problem today. In the next class, I'll solve a statically indeterminate problem, and I'll also project the table which will be given to you. So now one thing before we come to this problem, one or two students have mailed to me that formula should be provided in the exam. Now, my feeling is I can give you the formula, but the formulas which we have are very few. If you go through the entire course, there is a formula relating E, mu and G. Then there is one formula for bending and one formula for torsion and one formula for shear force and bending moment. If I give you the formula, then the marks for writing the formula will become 0. Understand this. If I don't give you the formula, and if you at least put that formula, which the right formula, at least you will get some marks. So now you tell me if I should give you the formula or not. मेरे ख्याल से तो नहीं देना. सिर्फ फॉर्मूले क्या है, कितने फॉर्मूले हैं, एक मेरे को खुद भी याद नहीं है, बट यू हैव टू रिमेंबर देम. देयर इज वन रिलेटिंग ई, जी एंड न्यू, shear stress and shear modulus, that is direct formula. What else is there? Then there's a torsion, tau is equal to whatever, and then there's a formula for bending. Now I'll go with the majority. How many of you say the formula should be given? How many of you say it should not be given? Normally, when decisions like this are taken, democracy doesn't work. But here, teacher की चलती है, but here I will go with democracy. So please, formula याद कर लेना तुम 4 लोग. I think only 4 of you raised your hand. So remember the formula. I'll not give you any formula, but I will give you the table. This table which is needed. I don't expect you to know all this. So let's just solve this problem today. So now I'll send a mail also. Formula will not be given. क्योंकि उसमें फिर लिखोगे तो कुछ नंबर तो फॉर्मूले के मिल ही जाएंगे ना, मतलब एटलीस्ट. ओके, ये क्या हुआ? I'm taking, I think, examples from the book so that it will be easy for you to. So here we have given a loading like this, where there is a uniform load and a concentrated load at D. And it says find the deflection at D. So this problem we can write it as equal to So we look at this problem and we divide it into two parts, just a uniform load and a point load. Now, this table, you can have a look at it in your book, but I'll present it in the next class also. What the table tells us is, for this load, y is equal to w upon 24 EI times x4 minus 2lx cube plus. This you don't have to remember. This table will be given to you that for a uniform loading of load W, y is like this, and also the slope will be given in that table. We'll take more problems in the next class. Now for this one, what it says is, if this load is P, this is A, this is B, then the table tells you that x is equal to A, y is equal to minus P A square B square upon 3 EIL. So this you directly get from the table. Now all what you have to do is put in the values of P, A, B, and similarly the value of W, and the value of X will be equal to 2 meters here, or whatever, L is equal to 8. So get the two Y's and add them up. So if you have a table like this, and this is what engineers used to do earlier, that for different type of loading, you can then add up the two loadings and get your answers. One more case we can take. If I have a case like this, and I want to find the deflection at some point, now you know the table only gives me a uniform distributed load. So what will I do here? And this is where you'll have to think. What you do is, this is equal to so if you add the two, you get the right hand side, isn't it? And now you can use the same formula. In one of them it will be minus. If the formula is given for a downward load, then for the left hand side you'll have to use plus. Okay. Now also what you will realize is that in this case, let's say this is A, this is B. In case A, the deflection is like this. For case B, when you look at the second case, the deflection will follow the formula up till the point C. After that, there is no load. So that means d2y by dx square is equal to 0. So dy by dx is constant. So then it will follow the same slope. Just think about this. I'll leave you with this thought question. We'll continue with this in the next class. I will take up one more example and I will also look at the table D in the text and I will also throw the table. Now, अभी ट्यूटोरियल की बात नहीं हुई है. एक्स्ट्रा ट्यूटोरियल करना है कि नहीं? नहीं करना तो मेरे को कोई फर्क नहीं पड़ता, मेरे लिए तो अच्छा ही है. तो एक काम करते हैं, एग्जाम में तो जो हम पढ़ाएंगे थर्सडे तक, नहीं ये पूरा आएगा. ये तो 9th में है ना, ये तो पूरा ही आएगा. ये तो मैंने आज धीरे धीरे इसीलिए पढ़ाया, इतने सारे एग्जाम्पल कराए हैं क्योंकि इसका ट्यूटोरियल नहीं होगा. फ्राइडे को एग्जाम है, थर्सडे को क्लास होगी. थर्सडे को आई विल बी सॉल्विंग मेनली मोर प्रॉब्लम्स. इफ आई डू एनी थ्योरी ऑन थर्सडे आई विल नॉट आस्क दैट. ओके, बट आई विल मैं थर्सडे की थ्योरी थोड़ी सी मैं और पढ़ाऊंगा अबाउट स्ट्रेसेस इन अ सिलेंडर, which is an interesting concept. That's why I want to teach it. But I will not question from that, but I will solve more problems. Maybe what I can do is, okay, ये जो chapter 5, जो tutorial 6 है, वो Thursday के lecture में करा दूंगा. ठीक है, 6 and 9. 7 तो पहले ही हो चुका है, more circle. हाँ, ट्यूट 7, 6 and 7 है, तो 6 है basically. ट्यूट 7 भी है और 6 and 7 are. You will do 6 this week. तो ट्यूट 7 में नेक्स्ट लेक्चर में करा दूंगा थोड़े प्रॉब्लम्स. ठीक है, सो विल नॉट हैव एनी मोर ऑप्शनल ट्यूटोरियल. बट इफ यू वांट टू डिस्कस एनीथिंग विद मी, प्लीज सेंड अ मेल टू मी एंड फिक्स अप अ टाइम. Normally after 5 I am available in my office. So if you want to see me, I will be there. But मेरे को मेल पहले डाल देना, अदरवाइज मैं मिलूंगा नहीं. यहाँ हाँ, कोई और दिन का अटेंड कर लेना. फ्राइडे वाले का ट्यूट 6 नहीं तो अभी हो गया होगा ना. लास्ट फ्राइडे क्या हुआ, क्या टॉर्शन? हाँ, तो वही तो होगा. उसके बाद का तो मैं कराऊंगा ना. अब बेंडिंग का नहीं हुआ तुम्हारा? क्यों नहीं हुआ बेंडिंग का? पता नहीं, पर उनके 5 की तो सारी क्लासेस हुई हैं, तो बेंडिंग का ट्यूट क्यों नहीं हुआ तुम्हारा? कोई मिस हुआ है क्या ट्यूट? फ्राइडे में तुम हो ना, क्या बेंडिंग का ट्यूट नहीं हुआ अभी? नहीं, पर फ्राइडे वालों का तो हो जाना चाहिए था. कोई एक क्लास मिस हुई है क्या फ्राइडे की? नहीं, वो शुरू में तो सभी का, फर्स्ट क्लास में तो मैं फर्स्ट वीक तो किसी का भी नहीं हुआ. दो में डिस्कस हुई है, तो बेंडिंग का तुम लोग देख लेना और या किसी और क्लास में अटेंड कर लेना. अटेंडेंस की जरूरत नहीं है, मतलब बिकॉज अटेंडेंस में यू अटेंड विद अदर ग्रुप्स और यू कैन कम